We're going to go to a panel discussion discussing how we can fit all of these disparate missions together into something resembling an observatory that we planned rather than just taking advantage of. We have identified, thank you, each of you, for identifying a lot of science we can do in pairwise. I'd like to have people discuss what we can do with trios or more of these missions to try and really nail. I mean, there are some things such as PUNCH Parker Solar Probe observations will be able to span 9 orders of magnitude in scale, right? That's an example of something that we can do together that neither of us could do alone. And I think there are examples like that with trios of missions as well, and more, and with the whole suite. So we need to start thinking in terms of how do we reach beyond our silos that we have to do to fulfill our obligations to Joe, and really extend out into the science. Sarah.
Yes, so I'll pick up on that. I have a question sort of to all of you. Somebody was talking about the fifth eye. Who wanted to be the fifth eye? I think that was Sunset over there, but there's some, we've got competition. So we've got various middle corona. We've got, my question is for each of you, and pretty much all of you have something in your mission that does either the low corona or a complementary image of the corona. What do you think is the lowest hanging fruit for adding that capability close to the eye in terms of a science goal working with PUNCH? So Ricky, you grabbed it and you've already said you want to do this. Why do you want to be the fifth eye? And then you can pass it on.
All right, so I have my own pop filter, so I'm good with this. The science mission of Sunset is really to target that early acceleration of CMEs and to be able to knit that together with the full the full evolution of CME from its initial eruption through space to impact at Earth is one of those critical things that tie us together as a heliosphere. And, you know, it is what PUNCH and Sunset can do together. However, and this is the big however, and Joan, you're sitting next to me, so we need to do calibration because we're imaging in EUV. So we don't have the same sort of baseline as doing a white light imager. So we're relying on everybody else in order to do that calibration to be able to actually knit it together more seamlessly.
I was there during listen to down the line or
Let's go down the line. I saw a couple more people start to answer.
Yeah, we do have complementary observations as well to get CME acceleration that we can cross calibrate with Sunset, for example. We also have information though on things like the magnetic field, MHD waves that can, and density that from that you can derive plane of sky magnetic field. And by tracking the ambient magnetic information and plasma information from low and middle corona on the ground, and the radio data is an important role to play here too. We have had people such as Teresa, she's one of her papers was on one of my slides, that used the combination of those data to interpret what they were seeing in the in situ data from Parker, showing that what you were seeing was two interacting CMEs because she could trace back into the low corona where those CMEs were. And that was what you were seeing in Parker. So I think that's a very powerful tool. And now we're going to have PUNCH to provide this additional information and the first polarized information out at the greater heights to pull that all together.
100.
There you go. Okay, well, we don't have a problem with intercalibration, or let's say not as much as Sunset would do. Well, in a sense, of course, the Sunset and Proba 3 would be complementary to provide understanding of coronal sources, low corona and middle corona sources. So I think it just goes perfectly in the direction of what you might said. We should study how the CME propagate, originate down and propagate out. We will have perfect combination of low corona with the Sunset and Proba 3, plus the magnetic field measurements from beyond. And well, we'll go now to the punch field level, would really make a great way to measure the full acceleration. And the structure on the ground. I hope that others, to say what other missions.
Okay, so I must also point out it's a observatory class and it's just not synoptic. So it's a science mode. So you have 10% of the time for coordinate global observations. So there is a time allocation committee. I think for this community, anybody can submit proposals. So we are again focusing on the thermodynamics and the spectroscopic diagnostics in the low current. So already, again, everybody is talking about the source regions. With the closed regions, closed versus open, to me is actually very, very important where the boundaries are. Source regions of the solar wind, SIRs. So I think VLC 5303, because it's an emission corona, it allows you to really properly diagnose the plasma conditions. So along with the images, this spectral information, I think, will be very crucial for modelers as well, in terms of density, temperature, and other parameters as well. And just spoke about the coronagraph, but of course it is X-ray, two spectral, X-ray instruments, it is a near-infrared instrument and the in situ instrument being in L1. So, but just in the context of, punch, I think the coronagraph can do quite a bit of joint observations.
So I'd like to hear from Noor, and then Joe's been waiting patiently.
First of all, I think
Oh, Teresa as well.
the space of things we can explore together is so vast. And I'm going to comment on two things. First of all, you said, I think the question was about low-hanging fruits. Forget them. You're going to be surprised. You're going to get so amazing things. You'll just forget. And we did that with Parkinson's report a year at a time. We had a workshop for predictions. They turned out to be awful. That's the second thing. The best way to maximize the science is to share data between the missions. And between the two of us, we have been working together for a long time. I think if we at least share the quick look data between the missions, between the teams, that would be significant. Because that will really help us early on hit ground running, what are the best things we can focus on, what are the things we can definitely.
I can promise each PI of each mission, you will get our quick data the moment I do.
And so, for those, if you remember, know a little bit of history of art, in the art, there was a moment where artists were unable to paint the third dimension, and suddenly they start to do that in their history. So we as community, we are on days where we are unable to understand the third dimension, mostly because we never saw the third dimension. And I think PUNCH is bringing this knowledge. And every physical process happening in the heliosphere has a third dimension. And our understanding of those physical processes will be advanced for sure. And I'm talking from the scientific community, not just written.
Super, thank you. Joe.
So thank you guys for letting me stand up. So if you were to rewind in your mind 10 years ago and think about the capability that is going to come from not just PUNCH, but the multitude of missions that are assembled here in front of me, there's a whole multitude of outstanding scientific questions that we would say, I must answer that question. If I had the capability that you all have, not just within your mission, but within this group of missions, within this Helio Systems Laboratory, within the Heliophysics System Observatory, within the entirety of what we do, you would say, I would solve this, I would do this. And I want to know, one, what those questions could be. I'm sure there's a bunch of really great ones. I think the more important question, though, is how would you actually do it? And right now what I've heard, which has been wonderful, is data sharing, is data availability, is other things. That's a field of dreams scenario. That's I'm gonna build the field and somehow ghost baseball players will come from the cornfields and play a game that's magical, right? Who are those players that are gonna come onto the field? And how do we enable as a community these big questions to be addressed by the power that you all have?
Well, I always had a dream. I wanted to surf in a CME, but now my dream is almost true. Because Parker brought the surfing in a CME. Oh, sorry, yeah, inside. So, but yeah, I think the third dimension to understand the morphology of the heliosphere in general and all these structures is still an open question. We don't know how they are in not just the morphology, but also the internal structure. How to do that? I think it's a very complex problem that will need several, so we are building this